Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 13th of April. It is a Monday, and it is a day 3 in our rotation. So, hope you all had a wonderful weekend. Hope you got to relax, get away from school a little bit, think about other things. Hope you got to spend some time talking to people, maybe with your family. Maybe you got to go outside and adventure a little bit or do something fun and just kind of chill and relax this weekend. I know it's a little weird for me. The weekends kind of are blending together with the weeks because still got to stay inside, still got to stay isolated from people. So I don't get to do all the fun plans that I used to do on weekends. But, you know, it's still a nice opportunity to rest, relax, kind of turn my brain off a little bit and kind of take some time to think about me and think less about school. But we're back to week 3 of online learning, so this is day 11. It's hard to believe we've already been through 2 whole weeks of this, and I was counting the days today, and it seems like we have 42 days left, so about 8.5 weeks left of school until we get to June 9th, and we get to enjoy our summer, and hopefully things are a little bit different by then. We really get to enjoy and make the most of the summer that we have. Today, I wanted to talk about a couple things. I wanted to talk about a little bit about what happened last week, what plans we have for this week in terms of meetings and things like that, and then get into today's lesson a little bit. So first of all, thank you so much. My cat's here again. Thank you so much for those of you who made it to the video meetings that I had last week. I did 2 of those from about 1:30 to 2 o'clock on Friday and from about 2:30 to 3 o'clock on Friday. So I wanted to do those on Friday kind of to wrap up the week and everything then. Probably going to stick to doing once a week just because it's not been super well attended so far. I don't know if that's because people don't care, don't want to make it, or they don't have time. Either way is fine, but I'm only going to do those once a week still. But I would like to go back to doing by the period, right, by the class. So we'll do another video meeting, another set of video meetings, one for second period, one for third, one for fifth, and one for eighth, just so you can get together with the people that you normally see for those classes and we can talk in those periods. I feel like that might have been one of the reasons why it was less well attended than previously, or people just got busy or they'd seen my face already and they were fine. But people are still interested in those. I have talked to some people who still want to do those, so I'm going to keep doing them, even if they're not as frequent as I might like them to be, just because they're not super well attended. But thank you to those of you who made those. We'll get those going again at the end of this week. Okay, so for today's lesson, we're talking about something very, very important called functional groups. Now, again, in science, we always have to break words down. So, functional, what does that mean? If you're functional, you're fulfilling some sort of function, right? You have some sort of purpose, or if you're functioning, you're doing something, right? So a functional group has to do with how a molecule is going to act, how it functions, what it does, right? Okay, so it has to do with how a molecule acts. And what's a group? Well, a group has to be more than one thing, right? So in this case, we're talking about a group of atoms, a group of atoms that's connected together and serves some sort of function or serves some sort of purpose, right? So a functional group is a group of atoms that sticks together and gives a molecule certain characteristics or properties or functions, right? What's the number one function or characteristic or property that we're talking about in this unit? That's right, smells. We're talking about smells. So functional groups are the groups of atoms that give a molecule its smell or its function, right? So we're going to look at a couple different functional groups today. Miss Marnick goes into greater detail with all the different functional groups, but I kind of wanted to break them down a little bit for you for the first time, right? Okay. So we have up here 4 different molecules, and each of these molecules has a different functional group. Now you might look at this at first and say, hey, Mr. Adam, these molecules all look kind of similar to me. I see they have different molecular formulas. Some have O, some have N, some have double bonds, some don't. But they kind of look similar to me. I don't really see what you're talking about with functional groups. The first step with a functional group, if you're looking to identify what it is or find it in a molecule, the first step is to look at one of 2 elements right now, oxygen and nitrogen. I want you to seek those out in these molecules and find where oxygen and nitrogen are in each of these molecules, right? Okay. So first of all, we have our oxygen up here, right? So that's what we want to find when looking for a functional group in a molecule. Over here we have nitrogen, right? Okay. Down here we have multiple oxygens, right? So this oxygen and this oxygen. And this one over here we also have this oxygen and this oxygen. Okay, that's a great start for functional groups, right? Finding those atoms and starting to pick them out. Now I've drawn some lines around here and we'll go a little bit further into why I drew those lines the way I did. Okay, first step is you want to find those oxygens and nitrogens, right? So you want to find those, identify where they are. And now, after that, you don't want to completely ignore the carbon and the hydrogens, but you want to find the other elements first. Now you want to see how all these connect together, whether they connect to a certain number of carbons or they connect to a certain number of nitrogens, right? Or how they connect, how they're ordered together, right? For this one up here, we have a double bonded oxygen to a C. That's a great start. But we have that here too, right? We have oxygen double bonded to C, oxygen double bonded to C, oxygen double bonded to C. But these are different. They have different functional groups. How are they different? Let's see. For this one, it's connected to a C, and that C, that carbon, is connected to two more C's on each side. That's really, really important. Seeing that you have a carbon connected to two other carbons, seeing what the oxygen connects to and what that carbon connects to is really important. It might seem not super important right now, but you're going to see that these puzzle pieces kind of fit together a little bit different. All right, let's look at this one. This oxygen, again, connected to a carbon, double bonded to a carbon. That's great. But what is that carbon connected to? It's connected to one carbon over here. Okay, that's fine. And it's connected to an oxygen, which is connected to a hydrogen. Okay, so your functional group here is this double bonded oxygen connected to C, which is connected to O, which is connected to H. So you're going to see pieces and parts. Okay, last functional group over here. What is this connected to? Double bonded O connected to a C. Okay, it's a good start, but all those have that same group. But this C is connected to a C on the backside. Okay, and it's connected to a C. Right? This O here, the C is connected to an O, single bonded to an O, which is connected to another C. Okay, so if I kind of just erase this part, right? What you're going to see is that these two molecules are a little bit different. They both have a C double bonded to an O, and they both have a C single bonded to an O, right? They both have that. But this one's connected to an H. This O is connected to an H, and this O is connected to a C. So as Ms. Marnick says, this one says COCO. If you look at it backwards, it says cocoa. And this one says HOCO. It says hoko. So this one smells sweet like cocoa. This one smells like feet, like homecoming. That's what she says. So these functional groups, you want to pick out oxygen and nitrogen. And then you want to see what's connected to them. And then I didn't go over this one. Nitrogen is connected to carbon here. Yeah, it's connected to two hydrogens as well, but you have a carbon connected to a nitrogen here. That's what the functional group is. Now these all have different names, and the functional groups are called different things, and the names that these molecules, that these chemicals have, will come from those different functional groups. So when you are looking for functional groups, look for O, look for N. See what those are connected to, okay? And then see what connects to those O's or to those N's, right? Okay, and that's going to tell you what the functional group is. So let's look at a couple examples of different functional groups and what those different molecules mean. Okay, so I have these things called alcohols here. I'm gonna put this one down for right now. But I have these things called alcohols here. Anytime I say the word alcohol, obviously what comes to mind is adult beverages. People start laughing when I say alcohol or start giggling and start going, ooh, he said alcohol. It's a bad thing. Well, alcohol isn't just the things that you find in adult beverages. And alcohol is actually a group of chemicals. There are actually many, many different kinds of alcohols, right? The one that everybody is familiar with is called ethanol. And that's what we call grain alcohol. That's what you find in these adult beverages. And what you'll see with grain alcohol is it's C2H6O. But what's special about it is it has this group where you have an O and an H at the end, and that's connected to a C. So this O and H is called a hydroxyl group, and when you have a hydroxyl group, it makes something an alcohol. So, what's this then? Does it also have an OH group connected to a C? Yeah, it does. And so that makes that an alcohol. These are both kinds of alcohols, but they're different molecules. They would have different smells. They would have different properties, right? This one right here is called isopropanol, or isopropyl alcohol. Have you ever heard of that? I would think you probably have, right? I have a bottle right here of isopropyl alcohol. This is what you generally find at the pharmacy. It's generally what's used for rubbing alcohol, right? So it's used as a disinfectant or for other various things. What does it say? Helps prevent the risk of infection in minor cuts, right? So it's used as a disinfectant in pharmacies and in medical establishments. It's sometimes used in hand sanitizer as well, and it's an alcohol. Okay, so these are both kinds of alcohols. They would have similar properties, but they would be different from each other. Last one we have is called methanol. Okay, this one only has one carbon, but it still has that OH group, right? That OH group is hydroxyl, and if it has it, it makes that called an alcohol, right? So this is an alcohol. This is called methanol or wood alcohol. So it's actually made from wood, and it's used in things like antifreeze, paints, production of other various chemicals, right? So this methanol is completely different. It's a different molecule from this ethanol and this isopropanol. They're different molecules. They have different properties and different uses, but they're all called alcohols. What's going to be different about these, besides their properties and their uses? Think back to Unit 4 when we talked about this thing called toxicity, right? So these are going to have various levels of toxicity. Ethanol, obviously we know we could imbibe a certain amount of ethanol and survive and be okay. It would still be toxic at a certain concentration, and it wouldn't take too much, but less toxic. Methanol, on the other hand, up here, right? Methanol, if you were to drink methanol or ingest methanol from antifreeze or paint or whatever you would find it in, it would be bad news. Methanol would go into your liver, and your liver would convert it into this thing that we call formaldehyde. And if you've heard of formaldehyde before, you know that that's what's used to preserve specimen for things like anatomy and physiology that you might dissect, right? It's what they used to embalm mummies in ancient Egypt. So, methanol, if you ingest it, bad news, because it's going to make formaldehyde in your liver and start embalming your body from the inside out. Pretty crazy. Isopropanol, same thing. You would want to use it topically, you'd want to use it on your skin to disinfect something, but you wouldn't want to drink it because, again, it would be fairly toxic to get in your system. Your body couldn't process it and handle it as well as it might be able to handle ethanol. All right, last set of functional groups. Now, why I'm showing you these is because these are very important for our next few lessons. On Wednesday, we're going to actually do our lab lesson. Unfortunately, we can't do the real lab. I know it's very sad I'll miss lab day too, but we got to move on. So, on Wednesday, you're going to be talking about esters. We're going to be talking about synthesizing an ester, right? So an ester has a cocoa functional group, right? COCO, if you read it backwards. It has a C double bonded to an O, and that same C, that same carbon, is single bonded to an O. And then that O that has a single bond is attached to a C on the other end. So you see the cocoa, right? So again, these three molecules are different from each other, right? They have a different number of carbons. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5, 6. This one has 1, 2, 3, 4, 5, but it's arranged differently than this one, right? Because this one has 2 C's on that side. That one only has 1 C on that side. This has 3 C's on that side. This has 4 C's on that side. So they're different molecules. Even though they might have the same molecular formula, they're different molecules. Remember, we call those isomers. So these different molecules all have the same functional group. They're all esters, right? So not only are they called esters, but let's look at what they would smell like, right? This one up here at the top would smell like apple. This one down here is going to smell like raspberry. And this one here is going to smell like pear. So what do we notice about all those smells? They're all what? They're all fruity, or we would say that they are sweet, right? Because they end in 8 and they have 2 oxygens in there, the cocoa type molecule, right? So because of that, they smell sweet or they smell fruity. So functional groups mean that they're going to have a similar function or a similar smell Doesn't make them the same molecule, but makes them have something in common, makes them function similarly. So, you want to practice identifying these functional groups and molecules, picking them out, and to do that, again, you need to look for O and N. And then you want to see what those O and N are attached to, and you want to use the chart that you're going to be provided for the different functional groups to identify what kind of functional group that is. Figure out what its functional group is, what it might be named, what its molecular formula would look like. If you make those sort of connections and start making those connections in your head, you're going to understand a lot about smells, how they work, and about functional groups and molecules and how they work. Okay? So that's all I got for you today about functional groups. Ms. Marnick's video is going to cover each individual functional group very, very well, so make sure to watch that video, check that out. Finally, for the share of the day, kind of focusing on the outside world a little bit this week, okay? So I look outside, it's kind of rainy and cloudy and crappy today, but we're starting to see a little bit of spring. I saw a little bit of snow last week, a little bit of snow over the weekend, I think, or maybe it was at the end of last week. But anyways, it's starting to look a little bit more like spring. It's starting to be sunny, starting to see the sunshine more, the temperature's starting to go up a little bit. So share with me this if you feel so inclined. What is your favorite part of spring? I know as soon as it starts turning into spring, I start getting a little bit happier. I'm glad to see the end of the snow. I'm glad to see a little bit more daylight and a little bit more sunshine. So my favorite part of spring, I have so many, but definitely one of my favorites is seeing the sun more and feeling the sun more. And walk out on the deck and actually feel the sunshine beat down on my skin. And it's way better than just being covered in clouds all the time. So I hope you all have a great day. Have a good start to the week. Keep working hard this week. Keep working on those lessons, getting things done and getting things turned into me. Make sure you're putting forth your best effort because even though we're on pass-fail now, I'm still checking your assignments. I'm still making sure that we're all learning this stuff and progressing as we should. Okay? I will see you all tomorrow. Have a wonderful day. As always, let's get a 1, 2, 3. Clap on me. Happy Monday, everybody.